All right, let's kick things off with a real head scratcher in the AI industry today. It's a paradox that honestly seems to fly in the face of every business rule you can think of, especially when the stakes are this high.
So, in this absolutely insane high stakes race to build the world's most powerful AI, there's one resource that's more precious than gold: computing power. We call it compute. It is literally the fuel for this whole revolution. So, the big question is, why on earth would a frontrunner like Google turn around and sell that fuel to its direct competitors? We're talking about companies like Anthropic. It just seems like a massive mistake, but as we're about to find out, it's actually anything but. To really get this, you first have to wrap your head around just how massive the difference is here. You have pretty much every other AI lab out there, from tiny startups to huge corporations, constantly saying they're compute constrained. That just means they can't get their hands on enough processing power. And then you have Google sitting in this wild position of having so much of it, they're actually selling off their surplus.
And hey, don't just take my word for it. Google Cloud CEO Thomas Kurian lays it out pretty clearly. He says the demand from everybody else is more than they can possibly handle. That really sets the stage for our first big question. How in the world did Google build such an incredible lead in the first place?
Well, the answer is it wasn't an accident, not even close. It's the result of a very long game that they started playing more than a decade ago. This is where we uncover the real foundations of their AI superpower. So get this. 11 years ago, Google made a huge bet. They decided to design their own custom chips just for AI. You've probably heard of them, TPUs or tensor processing units. And this wasn't just a one-and-done project. It kicked off this incredible cycle of compounding knowledge. What they learned from their AI software, like TensorFlow, helped them build better chips. And those better chips, in turn, let them create even more powerful software. It's this amazing feedback loop that got them to where they are today, on their 8th generation of these chips. But look, having the world's best chips doesn't mean a thing if you don't have anywhere to plug them in. Google saw this AI tidal wave coming years and years ago, and they made 3 brilliant moves to make sure they wouldn't get stuck. They secured energy sources, they locked down all the land they'd need for data centers, and they totally reinvented how they build them. Now, this is where it gets really clever. They shifted from construction to manufacturing. Think about it. Instead of building a data center piece by piece, screw by screw, right there on the site, Google started pre-assembling and pre-testing entire rows of machines in a factory. That meant they could roll out new capacity at a speed that nobody else could even dream of matching. Okay, so now we know how Google built this incredible compute advantage, but we still haven't answered the main question: why sell it? And that brings us to their playbook, something we can call own your IP. This is the secret sauce to their whole business strategy. Corian just nails their whole philosophy in this one sentence. See, some other cloud companies are basically just resellers. They're distributing somebody else's chips. But Google, they own the entire technology stack, from the silicon chip itself all the way up to the AI models running on it. And owning your own intellectual property, man, that gives you so much power. You control your costs, which means better profit margins. You have a bunch of different ways to make money. And because your demand is so huge, serving both yourself and the entire market, you get the best deals from everyone else in the supply chain. It's this powerful, self-reinforcing flywheel. Which, of course, brings us right back to the trillion-dollar question. If you have this incredible, maybe even unbeatable advantage, why would you ever share it? Why not just hoard all that power and sprint to the AGI finish line all by yourself? And here it is, the key. The race to AGI is, well, it's astronomically expensive. As Kurian points out, you can't just rely on venture capital forever. Selling that extra compute power isn't some little side hustle. It's the massive engine generating cash to fund their own gigantic research and development. In a very real sense, they're getting their rivals to help pay for their own race to the top. But hey, winning the technical race isn't the whole story. There's another race going on at the same time, the race for public trust. And Google knows that they have to tackle the big societal concerns about AI head on. So let's talk about the two biggest fears people have: losing their jobs and safety. To push back against this, Kurian gives some real-world examples. A German insurance company used AI agents to make their process 99% more efficient, and they didn't lay off a single person. And the American Society for Clinical Oncology is using AI to help doctors sort through these unbelievably complex cancer treatment guidelines, a situation where getting it right is literally a matter of life and death. Another huge concern is the environment. Data centers, as you know, use a ton of power. So here, Google points to its industry-leading PUE, or power usage effectiveness. It's basically a score for how much energy goes into the actual computing versus how much is wasted on stuff like cooling. The lower the number, the better. And Google says they're the most efficient in the world.
So we've talked about the past and we've talked about the present. But where is all of this headed? Well, according to Google, the next big thing, the next frontier, is AI agents. Korean sees AI evolving in three pretty clear stages. Phase 1 was Q&A. You ask a question, you get an answer. Phase 2 was content creation. You give it a prompt, you get an image or a video. But the next giant leap is task delegation. This is where you don't just ask a question. You give the AI a complex goal and it figures out all the steps to get it done. So what exactly is an AI agent? Well, imagine telling your computer, plan my family's trip to Italy for next summer and keep the budget under $5,000. The agent would then use all the tools it has, web browsers, booking sites, spreadsheets, to actually complete that goal for you without you having to do all the little steps. And that brings us to the next massive bottleneck on the horizon. It's not about training data anymore, or even a lack of compute. According to Korean, the next great engineering puzzle is just cost. How do you make these incredibly powerful AI agents cheap enough for you and me to use for everyday things? Solving that is the real key to getting this stuff into everyone's hands. Which leaves us with this final, kind of mind-bending thought. If an AI writes the code, and another AI is doing the quality check on that code, what role is left for us? What does the future of work actually look like? It's a question I think we're all going to be grappling with very, very soon.